Welcome to Computer Vision Streams. I'm your host Anton, and today we will discover which software engineering best practices people discover in the first couple of minutes of vibe coding, even without prior knowledge about computer sciences. That is a very interesting topic because we all have seen news how large language models advanced in coding and how they can help in AI assisted coding, but vibe coding pushes it to the limit. It all started from this tweet of Andrei Karpaty, where he describes vibe coding as purely describing to cursor some task. Then this task will be implemented in the code. And if there are any errors, we will just copy paste those errors into the console and see what will be the recommendations of LLM, and we will just accept all the advices from coding agent, and hopefully that will fix errors and we will continue to advance. He concludes in this tweet, it might be good for throwaway weekend projects, but it might be still difficult to apply it to more serious work. I observed a lot of non-engineering people playing with vibe coding. They achieved some great results, but inevitably they struggle with stabilizing their code base, and we will see what kind of software engineering concepts they discover in the first couple of minutes of using vibe coding approach. So the first concept that everyone discovers, even my mother, by vibe coding, is a version control. So the situation goes this way. A large language model codes this big beautiful project with these features. Okay, if we are lucky enough, it works from the first site. Let's add this and change the color of a button. Oh no, large language models rewrited the half of our code base, and we lost our previous changes because non-engineers don't learn yet about version control. So they discover the need of a version control and the ability to return back to the latest working version quite rapidly. And in the modern instruments, the version control is already integrated. So that is nice. And why it's fascinating? Because just by pure practicing vibe coding, people will immediately understand the importance of version control. From my experience, even a couple of years ago, I still have seen engineers in some small companies that were not quite using version control in their work. Second scenario is about test-driven development, which is very important and one of the best practices for modern software engineering. And we will see how non-engineers vibe coding will discover this approach. Alright, ChatGPT, implement feature 1 and feature 2. Nice, we have the implementation, it seems working, but change feature 2 in this way, or add feature 3, or maybe introduce any other change. Oh no, feature 1 is broken, how can I fix it? And hopefully after a couple of iterations, they will understood, okay, we will use our previous lesson, we have version control, and it would be nice to add a couple of automated tests to check if any new changes will not break previous modifications that we have. Third important observation is working in incremental small batches. Hey Claude, please implement this multi-layer microservice architecture with Blackjack and Kubernetes. Or for non-engineers, it could be just the description of a product with multiple different features. The project was coded. Depending on the instruments that you are using, it might work more or less, but sometimes it might give a couple of errors and you are not sure where these errors come from. And sometimes those errors could be related to multiple elements in the system. So it might be difficult to debug and difficult to understand what's happening, especially for non-engineers who are not fluent in programming languages. Okay, they will learn this lesson quite rapidly, and they will start with a small project and try to implement different functionalities incrementally by using previous lessons such as version control and test-driven development. And just with a couple of first iterations of vibe coding, they will learn very important software engineering practices. If they haven't learned them by themselves, if they haven't discovered them by themselves, they will try to Google, okay, how to increase productivity of my vibe coding, how to get better results of my vibe coding. And they will see this lecture of Andrei at AI Startup School of Y Combinator, and this slide will be very helpful for them. AI-assisted coding workflows and how to improve them. Describe the single next concrete incremental change. Here we are talking about small batch and iteration. Don't ask for code, ask for approaches. Pick an approach, draft code, review, learn, pull up API docs, ask for explanation, wind back, and try a different approach. So here in wind back, we have a mandatory version control. Test, automated test, git commit, again version control, ask for suggestions on what could be implemented next, repeat. Basically also working in the small batches. They learn this, they continue, and there is an additional playlist of videos from Y Combinator about how to get the most out of vibe coding. We will see, pick up the right tools. The tools will greatly increase the large language model accuracy and will help large language model to get access to the files in the repository, get access to some chains of thoughts, how to better introduce modification into the code base. The first one, again, is a version control. Basically, you can just vibe code either very small or a throwaway projects without version control. Next, write tests, how to fix bugs, how to write documentation, so large language models could use it. In this step, it might be very interesting both for software engineers and for project managers. It's about how to specify what we are trying to code. And you will also learn a lot of best practices by interacting with large language models. Functionality, choose correct stack, refactor frequently, and keep experimenting. And funny enough, all these best practices for vibe coding is exactly the best practices of the best software engineers. And you can match them one by one with state-of-the-art DevOps, with continuous delivery, with modern software engineering. Take example, the recent book of David Farley, Modern Software Engineering, where he tries to outline the principles that standed the test of time and that help to improve productivity of software engineering. The two pillars are optimization for learning and optimization for managing complexity. In optimization for learning, we see our small, incremental, iterative work, construction of feedback loops, which includes not only automated tests and test-driven development, but also tests from the clients, A/B tests, integration tests, acceptance tests, and so on. Incrementalism, working in small tests. Empiricism, working with getting the data from your experiments and then deciding what to do next. And being experimental, applying different experiments to test this way or that way of implementation. And also, next step, when people vibe code, they will find out, it's actually very cool if I will manage to make my code modular, and I will limit the blast range of my large language model modifications just to some modules or some functions. And that will highly increase the output of good code produced by LLM and will be easy to debug and deploy. So to conclude, AI-assisted coding will, I guess, highly increase the productivity of engineers, and the better software engineers understand the best practice of normal software engineering, the better they will be able to introduce AI-assisted coding into their workflows and build better software faster. If you like my observation about computer vision and software engineering, don't hesitate to subscribe and like this video. I will see you in the next episode.